Hello guys, hope you have been having a very lovely day. In this video, we are going to learn about the controlling of a stepper motor using a DSP kit. So, controlling by using the DSP essentially, it takes two parts. One is the power electronic drive circuit, and the second is your controller, which is nothing but your digital signal processor. Now, coming to the power electronic drive circuit, let me just put it down as PED circuit. You have four switches, and let me put down the switches like this, transistors. You have the four transistors acting switches here, and these four switches are connected to your controller. And it is from your controller that you'll be receiving the gating signals. And all the V plus of these transistors acting switches are connected to a supply of about 12 volts through a series resistance. We will learn about the significance of the series resistance later in this video. And yeah. Now, as you all know that the windings of a stepper motor have inductance, so let us draw the inductances of the stepper motor windings. There we go. Okay. So, and this is the controller. There we go. We're all good. So now, what do you know about inductance? You know that an inductance has the property of storing current. So the working of this circuit is pretty simple. When this switch is on, when this specific transistor or switch is on, this winding is given with some amount of current in supply. So the property of inductance is it doesn't reach the peak value of the current immediately. So it actually limits the working of the circuit because the speed of this stepper motor is dependent on the frequency of the circuit. So if the current is not reaching its peak value at the proper time, then that is going to be a problem. So to eliminate this, we have this series resistance connected over here. So this will help the inductance to reach the peak value of current in the proper time. So in the same way, when this switch is on, this winding is energized. When this switch is on, this winding is energized, and so on. So now if we look at the other side, the same problem occurs when we actually turn off the switch. When the switch is turned off, the current left over in the inductance doesn't dissipate quickly. So it actually doesn't have a path to dissipate. So in order to eliminate that problem, we connect a freewheeling diode across each winding. So when the switch is turned off, the current left over in the inductor uses a freewheeling diode as a path of dissipation. So this is how the power electronic drive circuit works in the control of a stepper motor. Now coming to the controller part, a controller, we mostly use the LF2407. I'm talking about the TMS 320F2407. So now this has the four input-output ports, and it is from these ports that we give the gating signals to the transistors, and the transistors in turn energize the windings in whatever sequence we specify. And the speed of the stepper motor is determined by the switching sequence of the transistors we do. So this is very much how the stepper motor can be controlled by using a digital signal processor. Hope you found it informative. Thank you for watching. Have a lovely day.